So, if you took Australia as a uniform paddock, every year we export about 20% more nitrogen in the grain than is brought in by fertiliser or legumes. So it has to come from somewhere, and one of the reasons organic matter is going backwards in a lot of cropping soils and has gone backwards in the past is because we've extracted more nitrogen from the organic matter. So to build that organic matter back up, the nitrogen has to come from somewhere. Now that's not from...
8%?
It is, but that requires nitrogen fixation. And the things that are primarily doing that are your legumes. So if you've got a legume pasture, yes, you're probably fixing an awful lot of nitrogen that is staying below the ground. But if you're not, and even if you've got legume grains, a lot of that nitrogen is being taken back off in harvest. So although you wouldn't be applying nitrogen in those years, you would still need to be applying nitrogen to offset what you're taking off in the grain. Beyond, the numbers just don't stack up. There is a small amount of free-living nitrogen fixation, but you're really looking at single-digit numbers per hectare per year.
Is it only leguminous plants that fix a lot?
Yes.
So how does the trees grow in the forest?
Most of the nitrogen that's in soils, if you look at succession of natural bush, you'll see the acacias generally come first. And the acacias are nitrogen fixers. There isn't, and the other thing you've got to bear in mind, in a natural system, you're not exporting biomass each year. You are, but then the tree falls over and most of it ends up back in the soil, and over thousands of years those small amounts build up. But we're greatly changing that by exporting grain from the system. So yes, whilst 80% of what we're breathing now is nitrogen, I was slightly amused that there was a dangerous chemical spill in corn yesterday that was a liquid nitrogen tanker. Yeah, it's not... It's dangerous in the context that it's a cryogenic and it'll burn you, but it's not going to do you any harm unless you stick your head under it. But at the same time, the reason that it's so inert, it takes an awful lot of effort, energy, to get it into a form that is reactive and usable by plants. Now, obviously, we've short-circuited that with the Haber-Bosch process. The other way is through biological fixation. But the reason that natural systems sustain themselves in the way that they do is there isn't nitrogen being taken back out of them. Again, that's not to say that indiscriminate and inappropriate use of fertiliser is a good thing either. It's very much, it needs to be handled with care. But if you take the system as a whole, as an average across the whole of the grain growing region, you're about 20% short at the moment, and that has to come from somewhere, and it isn't being backfilled by natural fixation. Are you happy to leave that there?
No,
yeah. All right.
Okay, I've got a question. Yeah. I'm up here, Tracy. You sit down. So to me, and this is probably to Amanda, maybe, to me, the first step a farmer should probably take in this soil carbon space is to determine their set capacity for their soils. And so how does a farmer, especially in, say, a low rainfall, mallee farmer, how would he go about doing that?
If the farmer has got soil test records that they're using in their cropping system anyway, they can use those results that they collect them. They're normally taken from 0 to 10 centimetres, and you can use it against those benchmarking values we have in that report. It'll give you an indication of where you would sit in there. It'll give you that chance to see if you've got potential to increase. You could do some specialised soil sampling if you need to just go out and collect samples in your own paddock, not just for nutrition testing, but you can just do carbon. Lots of the labs will just look at carbon tests as well. It's a bit cheaper than a full nutrition. So there are some options to start there. But those benchmarks are a good handy way to just go back and get a guide of where you fall within those areas.
So that leads on to another question. And that, so the international standard is 30 centimetre, but most farmers have been 0 to 10 testing.
That's a really good question. So within that report also, we had a look for the results that had actually measured deeper in the soil. Because like you said, most people only look at 0 to 10. So we have looked at what happens in that 10 to 30 centimetres and then often below 30, so 30 to 50 centimetres, often hitting clays. And we could see what the trends were. So by texture, roughly in your 10 to 30 centimetres, you're expecting maybe 75%, between 66 and 75% of the carbon of that topsoil layer. So it will give you a rough indication. Below in the subsoil, you can have roughly anywhere between 10 or 30% of what's in your topsoil. So if you can't subsoil, or if you can't test down there, you would only go to 30 centimetres generally. One, if you're looking for any subsoil acidity or any limitations in there, or two, if you're talking about carbon accounting, because majority of your processes and your nutrients and your microbe is occurring in that 0 to 10 centimetre depth.
Now your turn, Tracy.
Thank you, Andrew. I had a question probably also to Amanda about what are the carbon methodologies in agriculture that are relevant in South Australia, and are there some examples from the 24 projects that you had on your slide? What are the sort of projects that people are having a crack at?
So if you go onto the website, so if you get the PDF, I've got the websites that you can go and look up. So on the ERF, you can mine down and you can find out that the details about what methodology people have used. So what they've used, either an agricultural method, so soil, or a vegetation method, which could be avoided deforestation. Doesn't happen here because we don't clear our trees, but happens in other states, or revegetation. So there's a couple of useful ones. The CSIRO tool, the Look-See that I spoke about, I'll send that also in an email that you can look up. That will give you a good grounding about what methods might suit your farm in your area. It takes into account soil type and rainfall. That's really handy. And Bonnie Armour, who's hiding in the back there, she has done a fantastic literature review for the Murray-Darling Basin, or the Mallee areas, about looking at methods, carbon farming methods that would be suitable for the area. So what I'll do is, there's a great table in her report. I will send that in to Tamika as well, and she can send that out to you as well.
Thanks, Amanda. Any other questions? Chris.
To me, the whole soil testing thing is just so all over the place. I mean, you'd almost, if the farm is starting, you get it to take a heap of samples and then choose the lowest one as their baseline. But on from that, hopefully make it look better in the end. Because it just, I know, I've soil tested many times across the same paddock, and you get such a variation depending on a whole lot of things. It's not an exact science. But is the
Hold it, just so everyone can hear.
okay? So is the proposed gains that you're trying to get carbon credits for, is that based on, okay, well, I'm using this farming system, therefore there's a formula for I'm putting this much carbon back in my soil, so that'll be the basis of it? Or is it just based on, you measured it here, you measured it now, there's the difference, this is how much money it's worth? Because then, again, what sort of... if it's done on, okay, for this farming system on this soil type, we can use this model, then, how sure are those models?
That's a really good question, Chris. There are two methods for soil carbon that you can use. There is one that's called the default method. So far, not one person has taken that up. So it does rely on that idea of how much for your soil texture, for your rainfall you would do. And I think that they're very conservative estimates, so they're quite low. So at that lower price of $16 a hectare, it's probably not worth it as such. So the other method that they use and that people are looking for now is that measurement base. So you take on day 0 and then you measure again in 5 years basically, and that's what your changes is what you will either be paid. You can then go to another 5 years' time and you can either increase or decrease. So it depends on how you go. So you're looking at that change in carbon stock basically every 5 years for 25 years. In your question about on your farm and looking at there definitely is you want to look for those soils that have the greater opportunity for carbon. So the lower the baseline is, it's probably the easier to increase. But you also have to take into account that it's really much harder to increase on a sandy soil than it is on a loamier soil. And what biomass you can possibly grow. So your rainfall zone is really important too. So to just have those ideas of how much you can grow, those trend lines of how much carbon might increase can give you kind of an idea of in your area what you may expect to do.
The sort of that sort, like regardless sands are at 0.2, or lower, organic carbon, you can have notes on cropping and not shift it much at all, because if you get more turnover, but not necessarily shift that number. But I think what you said before about when you introduce some clay spreading, it actually gives the ability for more carbon to hold in those soils as well.
Definitely so.
Maybe it has to be a combination of things.
It could be. For sandy soils, it really is about that opportunity to protect it from degradation by microbes. So, I mean, if you're looking for carbon function, you really are turning over. You've got that carbon flow and that flux is going through, your nutrients are being available. But you do in a sandy soil have a limitation of being able to build it. So if you can add something like clay, and we've shown that adding clay can improve carbon, it doesn't always improve yield sometimes, depending on your rainfall zone and how much you put on. It can have, you can have negative effects. But you have to weigh all of these things up and apply as much as you need. There's opportunities, and Mark would know a lot more about biochar and other organic products that are longer lasting. So some of them are showing that the Great Mark compost that has been applied on sandy soils has had some longer term effects, not in carbon itself, but in providing an environment for those microbes to be able to store and turn over some more carbon. So in sandy soils, it can be really, really hard to increase carbon, particularly if there's been a long history of stubble retention, no-till, good practice. So, you know, farmers have done such a brilliant job about who would have thought that you could grow so much in such little rainfall 10, 20, 30 years ago. So sandy soils are tough. Did you have anything?
I think you've got a... Tim?
Thanks, Andrew. Probably more of a comment just following on from that. So I work for the Department for Environment. I look after a soils team, and a lot of our effort is actually monitoring soil health and condition across the state. And I've been around longer than Chris McDonough here, and I can remember what the mallee was like in the 80s. So is there any farmers here that were farming in the 80s? There's a few. So from the monitoring we just do at a very broad level, the soil, the landscape is in far better condition than it was 40 years ago. And we are still improving. Amanda had a graph of soil carbon actually going up. Now, I'm not as confident that it's actually going up, but it's not going down. Don't be fooled to be what you're hearing from the eastern states is that your farmers have buggered up the ground. You're actually improving it. The last 20 years has really proved that, in particular, the no-till system, the much higher production. In general, not everywhere, but in general, you're nearly growing 50% to twice, or nearly twice as much biomass as what you were growing 20, 30 years ago. And that's because you actually, even your pastures, you're sowing cereals and whatever for grazing. The amount of biomass is so much higher, your organic inputs are higher. So you're actually turning over more carbon, and as Eliza was saying, your biology is actually working. You're not fallowing, you're not actually working it. You've got more cover longer through the year. Okay, there might be a bit of erosion here and there, but in general, things are so much better. And there's actually a guy, he's actually a private consultant, Peter Treloar, used to work in the mallee with Gupta. And he's been measuring soil nitrogen. There was a question about nitrogen before. And he's been measuring it under a long-term no-till system compared with one that's been worked. And he was always finding more nitrogen there than what should be there based on models, and then you go back and sample again and it'll be the same result. So there's something happening there that even the scientists don't quite understand. They're going back and revisiting it. But it takes about 10 years. You change your system, it takes about 10 years. I used to think it was 5. Now we know you change something in your farm, you're not going to measure any real impact for 10 years. It takes the soil biology that long to adapt. It does adapt slowly. It can be longer, it can be shorter, depending on the environment. But he's finding that the amount of nitrogen being mineralised in the soil now it's unaccounted for. It's much higher than what he would envisage it to be. So whether it's free living and the rainfall we had in January really promotes that free living in fixation. So yeah, in general, things are so much better. There's localised issues, and that's what farming's about: is understanding your soils and overcoming your problems. But really, you guys have done an absolutely amazing job, and what we say is the soils are probably in the best condition they've been for 60 to 80 years. They were really bad in the 40s, but you look at them now, they're nothing like that. And if we had the farming systems we had 20, 30 years ago, the mallee would still be blowing now, even after last year. But we're not seeing it, so.
Thanks, Tim.
I'll just quickly, just to follow up on what you've just mentioned there and the nitrogen and just general fixation conversation. I think there's just a point there that we do really need to recognise is just the unknown. When it comes to ID in terms of soil biology, I think we've ID'd like 2% of what is there. So there's an awful lot of soil biological systems that we haven't even identified. And if we haven't identified them, then we don't know their function. So I guess like all these gaps in the system, we do have to recognise when there's stuff that we just don't yet know. And I think it's probably exciting. I think it's an exciting thing.
Right, we have a question over here.
We're talking about biomass, and I'm just wondering if all biomass is equal. Barley tends to stubble break down quicker than what a rye does. How does that all affect the end result?
Who wants that?
I can hopefully contribute some of the answer to that. So if you recall that earlier on in my talk where I talked about the different fractions of carbon, so the breakdown of stubble is dictated both by the chemistry of the stubble itself and also its physical form and interaction with the soil. But that doesn't necessarily mean that more of the carbon, just because the stubble breaks down quicker on the surface, doesn't necessarily mean that more of the carbon has been lost from the system. It's been turned over quickly into those pools within the soil. So legume stubble we see disappear quite quickly. That doesn't necessarily mean that more of the carbon has gone over a longer period. In actual fact, things like wheat stubble, you lose 90% plus, whereas legume stubble, you might only be losing 60% of it as offers CO2. And that's because it's easier to turn into organic for microbes to handle and stabilise and turning. Microbes are taking up carbon for 2 reasons. 1, because they need energy, and 2, because they want to produce more microbe. And the less carbon a microbe has to spend on energy, the more it can put into making more microbes ultimately. That's the main reason microbes are existing. Think of it in similar terms to having to go out and grow your own food and all the energy you've got to put into that versus going down to McDonald's. You probably get more reward out of growing your own. But nonetheless, the energy required for you as an organism is much less than it is to go to the trouble of farming yourself. And the same goes for microbes ultimately.
I think we have to remember what was the purpose of that stubble that you needed it for. So stubble returning into the system as carbon, but it also makes shade and moisture conservation too. So it is that double-edged sword, particularly in environments where we have lower rainfall and high temperatures. Just that protective capacity which is why it's really important to have cover in our soils from that point as well.
And just one final point, it wouldn't matter what the stubble was when it comes to the stable carbon in soil, because the stable carbon in soil is mostly dead microbe, rather than, it was once stubble a long time ago, but by the point you've got to the really stable stuff, it didn't matter what the input was, and indeed, sugars from root exudates, that's where this keeps getting mentioned. They go straight into the microbe, and the microbe can use them much more efficiently than having to produce all the enzymes to break down something that's really recalcitrant to get it the little bit that it needs.
Thank you. David, you've got a question. Can you speak loudly?
Is there any value in natural scrub, or is it being calculated into carbon credits for, like we own heaps of scrub land, is there any carbon credit, or how do you calculate that, or does it not work? Is it worth anything, I suppose, what I'm trying to ask?
Are you talking about in the soil or as above ground vegetation method?
As both, but as a carbon credit, is it value to us like our scrub land?
I know in the Integrity Ag reports, when they're doing carbon neutrality, they're taking into account scrubland and accounting using full cam actually is putting a figure on it to have accounts. I'm not sure in low rainfall, sandier soils, if we can get the growth rates that you would do if you're just looking at just continuing growing that you'd have enough there. Biodiversity values, markets are coming into it. There be value in that as well.
Just one of the key points there is it has to be a practice change. It has to be something new. So it's hard to get, because ultimately it's against what the atmosphere is seeing right now. So if you've already got scrub there, that's already not in the atmosphere. If you're looking at abandoning an area that wasn't particularly productive and you've always struggled to grow anything on and convert that into regenerate some natural habitat, that's probably a different question.
Just another shameless plug, but yeah, grab a flyer and come along to our workshop, because that's all stuff that's going to be looked at, discussed, and it's only open to 10 businesses, so it's a benchmarking workshop and it's actually going in depth. So they'll call you, they'll ask about your whole farming system, essentially your assets, and they're going to go through and create a report for you. So yeah, all of that stuff will be covered.
Actually, David, just we're part of Tracy's group, and when Integrity Ag look at your remnant vegetation, they actually take into account, I think, they take into account the age. So as remnant vegetation gets older, it's actually sequestering less carbon. So I think isn't that right, Tracy? They actually take in the age. So yeah, as it gets older, its value in carbon credit accounting becomes less and less. Other questions?
Yeah. Okay.
Mel.
Thank you. So we've ascertained today that most of us are in a low rainfall, sandy soil environment. We know that we've got deep, infertile sands at the top. Most of you've got heavier loams at the bottom. We might have organic carbon around 0.6 down to 0.2, we said before, on a deep sandy soil. So I wonder if that soil at all, if you could really call it that at that point. But anyhow, and then down the place we might be at sort of 1.2-ish sort of organic carbon. For any farmers are going to race home today and think, well, I better sign up now before I do any sampling. I guess there's that temptation that we go and sample by paddock rather than sample by soil type. And I'm just wondering if we drew our farm boundaries, would the recommendation be to sample all of your sand dunes? Imagine you've got no internal fences. Go and sample your sand dunes and work out the area of those you've got across your farm, and then your mid slopes and then your flats, and actually work out the budgets for each of those. Would that be more of a sensible approach? And are there any guidelines or recommendations or any projects that we know of that are trying to do this in our environment so these guys get it right? Because you don't want to get down the track and go, oh shit, we messed up the numbers at the start and now we can't, we haven't improved anything.
That's a brilliant question, and I have to say, unfortunately, for a lot of soils projects, are done on a paddock basis. So there can be stratification within a paddock based by texture, but in reality, if you could do that across your area and you group your areas that you think are the most likely, that would be the most logical way to do it. It's probably quite difficult, and I don't think it's occurring. Are you aware of anybody doing that as yet? No. I think it's been suggested quite a bit, but you need to have a company that is going to be able to do that for you. So I think give that 1 or 2 years, and I would say that could be quite standard when we have yield monitoring and remote sensing that can be overlaid on that to help do that. So I think that's coming, and I would say that would be a much better way of doing something.
Yeah, I guess too, it's something to think about that if you're going to invest in amelioration to overcome these constraints. And we've heard from Mark that the best way to build carbon is to grow more biomass, and the best way to do that is to overcome the underlying constraints in our soils, right? You know what they are. So if we're going to go then deep ripping or delving or clay spreading or any of those things, if we think about the cost of that, but then the potential benefit from an organic carbon perspective, you're not going to get the money back this year, but it might actually help, over time. And so don't miss the opportunity to capture that now so that you might be able to reap some reward from it later. But maybe this is a good project idea and something we actually need to kind of start thinking about so we can collectively think about the best approach in these kind of landscapes.
Mm-hmm. Good call, Mel.
Anyone with money? Tim, apparently you're the Mr. Moneybags.
Right, if there's no other questions, we might wrap this session up. No? Oh, yes, Chris.
In terms of carbon capture on farms, it seems like the best thing is to fence off areas and grow trees and, that you can actually see and measure real carbon and it's new carbon. Is that where the biggest opportunities are for our Mallee farmers if they want carbon credits?
If you're looking at sequestration credits and you're targeting an area of land that you are not going to use for cropping or grazing in that context, you could possibly go that way. There might be other ways such as emission reduction, such as getting livestock off faster, growing them, having faster growth rates, so you can look at just emission reductions. Sequestration, you have to do a lot of paperwork proving it. If you do an emission reduction, so if you don't apply fertilisers and you have a reduction in that, you can claim those abatements straight away and that year get paid for it, smack, done. So look for, and this is where the carbon footprints can be very handy, look for those really easier emission reduction things. So when we send out that list that Bonnie put together of methods, look also at those emission reduction strategies, not just sequestration. And I would just, I like the idea of planting vegetation and biodiversity, but I don't want to take any land out of that can be used for cropping or grazing, arable land.
Yes, Tracy. Time? Right, okay.